Now I would like to invite Jonas and listen to.
Okay, let me first start by asking, since we are also doing a project at the Andaman Islands, how many of you have been to the Andaman and Nicobar Islands? Oh, okay, it's quite nice. I see some hands every here and then. It's really like a paradise island in India, and I've been there a few times myself now. Okay, so anyway, the project that I'm representing is the E4T microgrid concept for the Andaman and Nicobar Islands, which is a bilateral collaboration between India and Sweden on microgrid, so it's in the same project. The members in my team is STRI, which is the company where I work, and we are experts in power system, both on the side that we are testing a lot of equipment and also on consulting. We have KTH in the team, which is the leading Swedish technical university, and I don't think they need so much of a presentation. We have Rajiv here in the audience, I can see, from KTH. Also we have Pamoya, who are experts both in microgrids with a long experience in Africa, as well as on biomass implementation. I will talk a bit more on biomass as well. On the Indian side of the consortium, we have Ahalya Alternate Energy, which is experts in renewable energy and especially wind power. And we have also Clean Bios Innovations, who are a consultant company with experts in biomass. Okay, so for those of you that have not yet been to Andaman Islands, you can see here on this map here where it's located. And I have pointed out Havelock Island, which is the main tourist place on the island, as well as Port Blair, which is the capital. And so let's take a little bit deeper look on Havelock, and we can see some interesting things here. We can see that there is a main road connecting something like 20 dots, and every one of those dots represent a hotel. And the main electricity grid on that island is run on diesel generated. As we can see here, I took a picture on some of the diesel that is there. And the main grid is so unreliable that every evening, every hotel is using their own backup diesel generator to supply their electricity needs. So from our perspective of trying to introduce renewable energy and trying to do a microgrid, we found out that the hotels would be an ideal site, basically, for a microgrid. And we can see also that there's a big scalability. I mean, all of them are very similar in size and needs, and they're all located basically next to each other. So we looked at this Havelock Island, and we looked as well on Neil Island, which is a up-and-coming tourist island of Andaman and Nicobar Islands. And the concept that we are introducing, the E4T microgrid concept, we are looking first on the generation side, which we can see here to the left. We are looking at how we can generate electricity by the use of solar PV, wind power, which we have found out that it's not a huge resource on the island. Also, we are looking at hydropower, biogas, and maybe mainly biomass, and to balance out the generation and load, we are using also storage, so mainly battery for storage. On the load side, we are looking at terminals, where we are putting at the different hotels a terminal where you can see the energy consumption and also control the loads to some extent. We are looking at the sector of telecommunication on the islands, if there can be some benefits of also including that. We are looking at tools and time-based loads, and finally we are looking at the transport sector, because also the transport sector there is run totally on gasoline right now, so we are looking at electrifying that. Okay, so I would like to go a little bit deeper into the technical part. I hope not to go too deep. So this is how it's looking right now for basically all of the hotels. This is based on my actual measurements on the island from several hotels. And we have a load curve here. So the axis is, y-axis is kilowatt, its effect, and the x-axis is hours. So we have the load for one day on a high season, basically. And what we can see is a clear evening peak starting around 6 o'clock. And we can also see that the main grid is supplying the electricity up until around 6 o'clock. And then from 6 o'clock during the evening load, all of the hotels are getting load shedded and they are running on their backup diesel generator. So we would like to make this in a more sustainable way, basically. And we have chosen to, for the next phase, which would be an implementation of a renewable microgrid system, we have chosen to focus on 2 hotels basically, and one of them is an existing hotel on Havelock Island, and the second hotel is a new resort on Neil Island. And the reason we are looking at a new resort as well as an established resort is that on a new resort we hope to be able to do some more energy efficient measures, since they are constructing the air conditioning system and everything, so we hope to be able to do something from the start basically. And at the existing hotel we would like to see how it's possible to kind of refurbish an existing diesel-based system. Okay, so let's go back to the load curve. That looks like this. So it's an average load curve of most of the hotels during peak season. First of all, we are introducing solar output. So this is from the rooftop solar of the hotel, and how much electricity you can generate, of course, depends for every day, but I want to show you an average example. So we have the solar PV output. And we are adding what we have found to be a major resource on the island, which is biomass. And in this case, it's the biomass of coconut waste, actually. And I learned through this project and working together with Pamoja that from one coconut you are able to generate something like 800 watt hours of electricity. So you can actually keep your laptop running for a few hours on the waste of one coconut. I think that's pretty fascinating. And we don't want to oversize the biomass system, so we are looking for this specific hotel at the 50 kilowatt system. And as we can see here, there's still some evening peak that our system is not able to handle. So we need also to introduce a battery. So we are discharging the battery in the evening, and of course to do this we also need to charge the battery during the day. So we have the charging when we have a solar PV, and discharging in the evening. And this is interesting not only for the Andaman and Nicobar Islands, but this is interesting because a lot of the loads and a lot of the problems in power systems all around the world is looking like this. Like we have a lot of solar PV or a lot of sunshine during the day, and then we have a lot of load in the evening, and we are looking at how to match this. And finally, I wanted to add one additional curve here, and this curve is if we would maximize the renewable output, if we would maximize the biomass as well as maximizing the solar, this is the load curve that we could supply basically. So another alternative would also be in some way to shift the evening peak, which is mainly air conditioning, to the mid of the day in some way, but I'm not gonna go into that too deeply. So this is how the capacities could look. This is preliminary results. So for the existing hotel, we have a 50 kilowatt peak of solar PV, 100 kilowatt of biomass generator, 100 kilowatt of storage, decentralized AC, which is how it's done there. First, the hotel makes the building, and then afterwards they put the decentralized AC units at every place they need cooling, and it's kind of inefficient actually. We are looking also at heat-driven desalination of water, as well as remote monitoring, so we can see from Sweden, for example, how the hotel is behaving. The second hotel, which is the new hotel on Neil Island, we have a somewhat smaller system with 50 kV peak of solar PV, 50 kilowatt of biomass generation, and 75 kilowatt hours of storage. And the main reason that we can make a smaller system at this place is that we can do some energy efficiency measures with centralized cooling and centralized heating as well. Oh, absolutely. Okay, and just something quick about the biomass is that we are using the pyrolysis gasifier to have the dry coconut waste, and from that we get both biochar, which is a fertilizer, and heat and electricity. And finally, I just wanted to say something about the market idea of this before finishing, and that is that for the hotels, this is generating energy savings. They are reducing the dependency of diesel, which needs to be shipped to every one of the islands, and we are also getting a cost that is lower than the cost of using diesel generation, both in the centralized grid and the decentralized locations. And the next steps will be to detail the design for the pilots, detail the business modeling, looking at integrating electric vehicles, tools, telecom sector, and finally finalizing the funding and then putting up the installation. So I hope this has been interesting for you, and yeah. So thank you for the presentation.